Hi guys, for the question 11 prac 4, Alana was asking me to produce a mini video to show you how it is exactly done by looking at the Aaron and Aaron tables. I have made mini videos in the lesson for that. In the middle of my mini videos, I have explained that. But just for prac 4, question 11, let's go through it properly. Now, it says that given that x is normally distributed, so x is normally distributed with the mean of 60 and a standard deviation of 10, sigma is equal to 10. Now, find the z scores for x is equal to 60 and x is equal to 72. For the x is equal to 60, okay, so we say z score is x minus mu over sigma. So 60 minus 60 divided by 10, so it's equal to 0. All right. Then in part B1, it says, what's the probability of x less than 60? So you want probability of x less than 60, which is equal to probability of z less than 60 minus 60 divided by 10, which is probability of z less than 0. All right, so to do that, you have to go to the tables, Aaron and Aaron tables, to do probability of x less than 60, which is the same as probability of z less than 0. Now, so in the Aaron and Aaron table, probability of z less than 0 is the same as probability of z greater than 0, because it is a symmetrical distribution. So probability of z, so under z you look at 0 and you will see your value in here 0, and probability to the tail is 50, so it is 50%. So you just make it as okay, what's the probability of z greater than 0 is equal to 50%. I'll show you how you do it. In here, I write it as probability of z less than 0 is the same as probability of z greater than 0. And then in your normal curve, you have got 0 in here. Probability of z less than 0 is this bit, and probability of z greater than 0 is this bit, and they are both equal to, each one of them is equal to 50%. Now let's go to the next slide, and we talk about okay, now we want to know what's the probability of x less than 72. So we know that x is normally distributed. Mu is equal to 60, sigma is equal to 10. Probability of x less than 72 is equal to probability of z. The z score for 72 is 72 minus 60 divided by 10. So x minus mu divided by sigma. So it becomes probability of z less than 12 over 10, which is equal to probability of z less than 1.2. Now, in the Aaron and Aaron tables, I have to show you for the probability of Z less than 1.2. Okay, so let's have a look. You can see that in here, probability of Z greater than 1.21 is 11.31. Okay, so probability of Z greater than 1.1 means the probability to the tail. Yeah, so just remember that one, which is 11.31. So we have got probability of Z greater than 1.2 is equal to 11.31%. Yeah. Now I want to draw it and show you how it works. See, this is the normal curve, and this is this probability of Z greater than, so we know that normal curve mean is equal to 0. Now probability of Z less than 1.2, we want this probability. Yeah, if this is 1.2, we want this we want this probability of X less than 72, which is equal to probability of Z less than 1.2. So we want this probability. Okay, but we notice that in the tables we only have got the probabilities greater than the value. So in the Aaron and Aaron table, it gave us this probability, 11.31%. Yeah, so we know the area under the curve is equal to 1. So if I say 1 minus actually I write it as 100%. Percent might be easier, so we say 100% minus 11.31%. So 100 minus 11.3 will give me 100 minus 11.3 will give me 88.7%. It's equal to 88.7%. So what did I do? From the Aaron and Aaron tables, I got this one, and then I subtracted it from 1, and I get the value that it's I wanted to. So it is 88.7%. Okay, now the next one is what is the probability of X between 60 and 72. So the question says, what's the probability of X less than 72 but greater than 60? Okay, so what does it want? It wants the mean, we know it is 60. So probability of X less than 72 but greater than 60. So it wants this area. All right. So there are a number of ways to do it. When we did the 72, we said that 72, X equals to 72 was the same as Z equals to 1.2. All right. So one way is in the Aaron and Aaron table, we have a look at percent to mean, because 60 is the mean. Yeah. And really we are looking at here probability from 0 to 1.2. So percent to mean will give me the exact value. And that is probability of x between 6 and 0.3849. 0.3849. All right. Another one would be I do have probability of z less than 1.2, which was 88.7, and I deduct, so I do have this value, all of this value. If I deduct 0.5 from it, probability of z less than 0 from it, then I will get this value in the middle that I want. So I will say probability of z less than 1.2 minus probability of z less than 0. Or in the other words, probability of x less than 72 minus probability of x less than 60. And this is the way that we do it for everything. And for example, I just show you if I want to do what's the probability of x between 50 and 70, another part of the question. So I have got probability of, so mean is equal to 60, and I want the probability of x between greater than 50 but less than 70. So I want this probability, okay, so you can just make a decision. It would be very easy to see percent to mean, and you say this, you get your z score for 50. So z would be z score, x is equal to 50, so the z score would be 50 minus 60 divided by 10, so it becomes minus 1. So I can have my standardized scores when the mean is equal to 0. So I want the probability of z between -1 and for 70, x is equal to 70. So it's the same as the z score would be x minus mu over sigma is equal to 70 minus 60 divided by 10. So probability of x less than 70 or would be probability of z less than 1. Yeah. So you really want these two probabilities. So you percent to mean, you get percent to mean for z score of 1 from Aaron and Aaron, and then you multiply it by 2, and that will give you the answer. So I can show you in the Aaron and Aaron tables. So in Aaron and Aaron, in the Z tables, I look at percent to mean for Z score of 1, and it is 34.13. Just remember that. So here, this value, percent to mean, is 34.13%. But then, as the normal curve is symmetrical, this percent is the same as this percent. Probability of z from -1 to 0 would be 34.13. So if you multiply 34.13% by 2, you get the probability of z between less than 1 greater than -1. And that is 68.26, which is the part 5 of part B of question 11. Hope that makes sense. Thanks, and remember to look at all the mini videos, because I have already recorded all of this for you in the mini video of the lesson. And then in your prac 4, you are going to look at the prac for the actually prac 4, which is in week 5. You are going to look at in the computer lab, you are going to look at the SKI and how to do make sense the probabilities using SKI software package. Thank you.